Hello to my Algebra 1 students. We are going to be looking at Lesson 77 together today. The title is Consecutive Odd and Consecutive Even Integers, and then we're going to talk a little bit about fraction and decimal word problems. So if you can recall with me, in Lesson 76, which was the last lesson that we did, I'm going to go up here on a blank sheet of paper here. We talked about consecutive integers, and we designated the letter n as some unknown integer on the number line. And we talked about a consecutive integer. To that, we would take that same number, n, our unknown number, and we'd add 1 to it, right? And then if we wanted to find the next consecutive integer, we would take the original number and we would add 2 to that. So in other words, if n was equal to 3, for example, then we would plug 3 in for n to get the next consecutive integer. We would do that for each one of those. And you would see then that we have 3, 4, and 5. So we have our consecutive integers. But what happens when we have consecutive odd or even integers? Let's think about that for a minute. Let's look at a number line here real quickly. I'm just going to put some numbers on here to make this easy. We'll go maybe like a -2, -1, 0, 1, 2, 3, 4, 5, 6, 7. We'll put 8 on there since I can fit one more. Let's say we designate the same letter n as our first unknown number, and let's just say that it happens to be a 3. Okay, 3 is an odd integer. What is the next consecutive odd integer? Well, it would be 5, wouldn't it? And then the next consecutive odd integer would be 7. So what would I have to add to my original unknown number? In this case, we named it 3. What would I do with that? I would add 2 to that, wouldn't I? So let's put 3 here. 3 plus 2 is 5. And then, of course, we would add 2 more to the original one here. 3 plus 4 then would give us 7, and that would give us our 3, 5, and 7, right? So you can see that you're skipping by 2 units now rather than over here when we skip just by 1 unit. When you're looking at consecutive odd integers, you're going to be skip counting, I would say, or skipping by 2 units, right? So we're adding 2 each time to our original number. So by the time you're getting to the third number, you've added 4. Okay, well, what about if you have an even integer? Let's just change the color of this so you can see them differently here. We'll make it green. So let's say n is, let's just say it's 2. Okay, the next consecutive even integer would be 4, right? So to that, we're going to add 2 to that. So 2 plus 2 is 4. And then, of course, to get to the next one, which would be 6, so we went from 4 to 6. But we're going to go, remember, you're always starting back with the original letter n, our original unknown. So when you plug 2 in for that, you get 6. So think about that. Whenever you're skipping now by 2 instead of just 1. Okay, so we're going to see some of these in action. And the first thing we're going to do is look at a word problem down here. And actually, it was actually in the book. So I guess I'm going to just add another sheet of paper here. We'll just go down right here. And I'll go ahead and keep my green pencil at it. Let's say we're to find, I'm going to write this in really quickly, that we have to find 3 consecutive integers. I'm sorry, consecutive even integers. Let's put the word even in here. It scrolled down on me. Sorry, guys. There we go. Consecutive even integers. And I'm going to write this out because I want us to be able to dissect this like we were the ones in Lesson 76, such that the sum of the first and second equals the sum of the third and -10. I should add into this, I'm having a hard time seeing our power went out about 45 minutes ago, so I'm actually connected to my Verizon. internet here, not my home internet, but just my Verizon cell service, and I have a lantern sitting here, so I'm trying to see my paper to get this lesson out to you by tomorrow. Okay, so here we go. All right, so we're going to find, let me change my pencil color here again to blue. So let's dissect this. So we're going to find 3 consecutive even integers. So let's name those over here to the left. So the first one's going to be n. The next even consecutive, I have to skip by 2. So I'm going to add 2 to n. The next one is going to be 4 away from my original number. So there's my 3 even consecutive numbers, okay? Such that the sum of the first and second, so the sum of the first and second, so we're going to go ahead and write that. The sum of the first and second would be n plus 2, that's my first and second, equals the sum of the third and negative 10. The sum of the third, which is n plus 4, and negative 10. So I could do plus a negative 10, or I could just put minus 10. All right, so let's add all this together. So I'm going to drop off the parentheses here. Okay, so we have 2n plus 2 equals n minus 6 on this side. And we'll move the n over here. And I'm going to do this in the same step, okay, just so you can see what happened there, okay? So n equals a negative 8. All right, so let me change my color over here. So n equals negative 8. So if I put negative 8 in for n here, what do I get? I get a negative 6. And if I put negative 8 in here, I get negative 4. So I have negative 8, negative 6, negative 4. They're all even, and they are consecutive even numbers, right? So they're like skip counting by 2s, in other words, okay? They're 2 units apart. All right, so that's how you would do that one. Let's look at another one here. See if I have room to write this. Actually, I'm going to add another sheet of paper here. There we go. All right, so this one says we're going to find 3 consecutive odd integers. This one time it's going to be odd instead of even, such that the sum of the first and third, sorry, it's a little tough to see here, is 7 greater than, 7 greater than what? The second, 7 greater than the second decreased by 18. Okay, so this is a little bit involved, but we see here that the first thing we want to do is we're going to find 3 consecutive odd integers. So think about that with me. So the first one we'll name n. 3 consecutive odd integers. Remember what we looked at before in the number line. Even if you do pick odd integers, that doesn't matter. You still skip 2 units for each one, correct? Like 1, 3, 5, 7. You're skipping by 2s. So if the first one is n, well then the second one you're still going to skip by 2. And the third one is going to be skipping by 4 from the original number. Okay, so that's that. We named our 3 consecutive odd integers such that the sum of the first and third, let's write that in. So the sum of the first, which is n, and the third, which is n plus 4. I'm really not going to need my parentheses on there, so I'm going to leave that as is because we're just adding all of those, is, which is our equal sign, 7 greater than what? 7 greater. Remember how we talked about that's going to be at the end because it's 7 greater than some number. So 7 greater than the second number decreased by 18. So that's going to be written like this. The second number, which is n plus 2, decreased by 18. So think about that. I'm going to put that in a parenthesis here because I want you to see this. 7 greater than what? 7 greater than the second number decreased by 18. So it's 7 greater than all of this. The second number decreased by 18. So be careful. Just follow your words. All right, let's go ahead and solve this thing. And I really don't need these on here. Okay, so I'm going to have 2n plus 4 equals n. Let's get our stuff together here. So 2 and 7 is 9. So a negative 9 here, n minus 9. And I'm going to go ahead and move my n over here. And I'm going to move my 4 over here. Subtract 4 from both sides. I'm going to end up with n equals a negative 13. Okay, so our first odd integer is negative 13. If I put a negative 13 in for n here, I'm going to end up with negative 11. If I put negative 13 in here, I'm going to end up with a negative 9. So there's our 3 consecutive odd integers right here. Negative 13, negative 11, and negative 9. Okay, let's do the one in the packet. I'd like for you to go to your packet. Number 1, find 3 consecutive even integers such that 4 times the first equals 16 times the sum of the third and the number 2. Now, if you would like to pause the video and see if you can set this up and dissect it, putting it together, and then coming back and seeing if you got the correct answers, you may certainly do that. Otherwise, you're welcome to just stay tuned and watch me work through this. All right, so we're going to find 3 consecutive even integers. Let's write those out. N plus 2, and n plus 4. Such that 4 times the first, whoops, I went a little too far. 4 times the first, here we go. 4 times the first would be 4 times n. My first number is n, equals 16 times the sum of the third and the number 2. 16 times, see what that is, 16 times, I'm going to put parentheses here for my multiplication sign. 16 times what? The sum of the third and the number 2. The sum of the third, well, my third is n plus 4, right? So the sum of my third and the number 2. The sum of my third number is n plus 4, and we're going to add 2 to that because it says the sum of this number plus 2. Okay, so we're ready now to do some math. So we have 4n equals 16. I'm going to do what's in the parentheses, what I can here. 4 plus 2 is 6. So 4n equals 16n plus, and 16 times 6 is 96. All right, and then I am going to subtract 16n so that I can get my n terms together over here. So I'm going to have a negative 12n equals 96. Let me bring that up here because I'm running out of room. I'm going to divide by negative 12. That'll make my n positive. And 96 divided by 12 is 8, so negative 8. So my first integer over here, I'll change my pen color so you can see where I'm at, equals 8. We're going to put a negative 8 in for each one of these n's. You're going to get negative 6. Put negative 8 in down here, and you're going to get negative 4. So negative 8, negative 6, and negative 4. There's your 3 consecutive even integers. Okay, see how that works? I'm going to do another one. I'm going to have you guys write one in down here because I want us to do this one's kind of a toughie, and I want to make sure we have a chance to cover this. Let me just make sure I've gotten everything in that I want, and I do. Okay, so here we go. Here's what you're going to write in. Write down underneath your practice problems. Let's write this in, and you can write kind of small. This is going to be example. Just another example. All right, here we go. Find 4 consecutive odd integers such that the sum of the first and fourth is 25 greater than the opposite of the third. All right, so let's figure out, first of all, let's designate our unknown numbers. So we're looking for 4 consecutive numbers in this case, okay? Not just consecutive numbers, but consecutive odd numbers or integers. 4 consecutive odd integers. All right, so let's name those over here. We'll designate them. I'm going to put them in a different color. We'll have the first one's always n. The second one is going to be n plus 2, right? They're going to be 2 units apart, and I need 4 of those. All right, so there's your 4 consecutive odd integers. Such that the sum, right here we're focusing on the sum of the first and the fourth, the sum of the first and the fourth. Okay, our first is n, and our fourth is n plus 6, and it's the sum. We're adding those 2 numbers together. So n plus 6, right? This would normally be in parentheses if you wanted it to look that way. We're going to drop them off when we solve, though. Is, which is always our equal sign, 25 greater than what? So we know that it's going to be plus 25 at the end over here because it's 25 greater than whatever is going to go right in that spot. So let's figure out what's going in that spot. 25 greater than what? The opposite of the third. The opposite of the third. Well, what is the third number? The third number is n plus 4, right? But they're saying the opposite of that. Well, the opposite of that would be negative that number. So let's just say the number happened to be 7. Okay, let's say that fourth number ends up being 7, just as an example. What is the opposite of that? Negative 7. So if the number is n plus 4, the opposite of that would be a negative n plus 4. All right, and I'm going to move this plus 25 over here. Okay, so there's how you set that up. If you want to pause the video and try to solve this, please feel free to do that. I'm going to end up with n plus 6 equals, and I'm going to go ahead and distribute this negative. Remember, we think like there's a negative 1 stuck in there. It's going to distribute to make this a negative n and a minus 4. Okay, so we have 2n plus 6 equals a negative n plus 21. We're going to get our n on the same side, and I'm going to move the 6 over here, all in the same step. So I have 3n on the left-hand side and 15 on the right-hand side. We'll divide that by 3. Your first number is going to be 5. Oh, did I make a mistake here? Oh, no, we're okay. Okay, so first number is 5. Put 5 in for every one of those ends there. 5, 7, 9, 11. Okay, and that would be how we solve that particular problem. All right. Wait 1 second here. So 5, 7, 9, and 11. Okay, all consecutive odd integers, and there were 4 of those. All right, we're going to move to the next part of this lesson, which is dealing with some examples of looking at fraction and decimal word problems right here. So we're going to do this part right now. I'm going to add myself another sheet of paper here so we can talk about a few of those before you do your practice problems. So where's that one? Okay, I've got a sheet right there. Perfect. Okay. Alrighty, so when we're talking about fractional parts or decimal parts of the whole, we're talking about doing some multiplication to find a fractional part of a larger number. So here's what we're thinking of. We use F for fraction. Fraction times of what big number? So we're finding the fractional part of some number will always equal the is number. So in other words, if I said 1/2 of 50, or multiplying, right, that would be like our of number. 1/2 of 50 would be like multiplying is 25. Okay, so think of it that way. The same would be true of a decimal. The decimal times your of number is going to give you your is number. Okay, because I'm going to use that verbiage quite a bit here. So in your book, you've got page 317. Yes, 317 at the bottom. They give you this word problem. I'm going to read it. I'm not going to write this one out. I'm just going to read it to you, and then we'll set it up. Lopez used a 5 iron. That's a golf club, by the way. But the ball covered only 4/5 of the required distance. If she hit the ball 112 yards, what was the required distance? So let's think about this. The ball covered 4/5 of the required distance. We know what the required distance, we don't know what the required distance is, but we know that the ball covered a part of that. She hit the ball 112 yards. So this is what you're thinking about. So 4/5 times the required distance, I'm going to show you something here, equals 112. Okay, so I think of it this way. So 4/5 of the required distance is 112. That's what's being said here. 4/5 of the required distance is 112. Because think about it. The ball covered 4/5 of the required distance. We don't know what the required distance is. That's what we want to find out. But we do know that the 4/5 part of that is the 112 yards. So we just solved this. 4/5, and we can multiply by the reciprocal here. Right, because that'll X that out. And when you do the math here, you're going to end up with, it's going to turn out to be 140 yards. The most important part here is figuring out how to set this up. Okay, but that's the fraction of, so 4/5 of the required distance is 112 yards. Okay, so what was the required distance? What's the total amount? 140 yards. Let's look at the next one on page 318 up at the top. Let's see here. McAbby guessed that the total was 30.24, but this was 7 times the total. What was the total? All right, let me get another pen color here. Okay, so we're told, hold on, it's just so dark in here, it's hard for me to see. Okay, here we go. McAbby guessed that the total was 30.24. But this was 7.2 times the total. Okay, so she didn't actually accurately guess what the total was. So we need to figure out what the total is. But let's set this up using a decimal. 7.2 times the total equals 30.24. Okay, so in other words, 7.2 of the total is 30.24. Okay, so that's how you set that up. 7.2 of the total. Yeah, okay, 7.2 of the total is 30.24. So we're going to go ahead and set this up. 7.2, we'll call that T. And you know what to do from here. You can have your calculator handy. You can divide that out. The total is going to be 4.2. That was the total. Okay, so she guessed a certain amount, but it wasn't correct. So we had to figure out what 7.2 is the part of what total. 7.2 is 30.24, but what was that a part of? Okay, so you had to figure out the total number, the larger number. All right, let's look at 77.6. 3/4 of the tickets had been sold, and there were 420 tickets left. How many tickets were printed? All right, so let's think about this. So there's the total number of tickets we don't know. And that's what we're going to try to figure out, right? How many tickets were actually printed, so that's the total amount. We are told how many are sold, and that was 3/4 of the total, right? And we are also told how many tickets are left. And that was 420, correct, Monday? Yes, 420. Okay, so there's 420 tickets left. All right, now think about that. And we're supposed to figure out how many tickets there were total. So I want to use the information that I have here. So 420 then is what fraction of the total? If what was sold is 3/4, then what is left must be the remaining fraction. So 420 is 1/4 of the total. So let's write this like this. So 1/4 of the total is or equals 420. So think about that. I like to do this little arrow here. 1/4 of the total is 420. So let's just rename total with a T to give it just a variable. We're going to multiply by its reciprocal on both sides. And the total should be larger than this number, right? And it's going to turn out to be, oh golly, I didn't actually finish this one. So 420 times 4, I'll get my calculator here. 420 times 4 is 1,680. That's the total. Okay, now let's go up top here. We're going to do the one in our notes. Oops, going the wrong way. 77, go down. Here we go. Alrighty. All right, so on the first day of the sale, this is number 2. On the first day of the sale, the girls sold 1/5 of their cookies. If they still had 384 cookies left at the end of the first day of the sale, how many cookies did they bring to the sale? So we're looking for this total amount. We know that they sold 1/5 of their cookies. We know how many are left. So this looks like the problem we just worked out. Okay, so we're going to write some things down here. So they sold, it says 1/5 of the cookies, right? Sold 1/5 of their cookies. What they still had left, they have 384 cookies left. So let's write this down. So what's left is 384. Well, what fractional part would that be? If they sold 1/5, then that means what's left is what? The remaining fractional part, which would be 4/5. But what we want to find out is what was the original amount or the total, how many cookies did they bring to the sale? So the original amount, or we can call it the total amount. Probably we should stick to the same term we've been using. So what was the total amount that was brought? That's what we want to figure out. Okay, so we use what we have. This is the information we have that we can put together in our equation. So 4/5 of the total, right, is what is left, which is 384. 4/5 of the total is 384. So we have something we can solve here. And when you do the math on this, you're going to end up with 480 is your total amount. Okay? So that's how you do that. Now let's go ahead and work on our practice problems here. Letter A, we want to find 3 consecutive even integers such that the sum of the first and third equals the sum of the second and -14. What I'd like you to do is if you can pause the video and you can work out letter A, and then you can come back on and just check your answer. You can just kind of fast forward your video here to see if you got the right answer. If you didn't, then you might want to back up and see where you may have gone wrong. I'm going to go ahead and work through all 3 of these. You can just pop back on to check your answers. And if they're right, move forward. If they're wrong, you can stop. I'm also going to just give you a certain amount of problems to work in this lesson. So I will let you know what that is Not in this video, but I will list those on Google Classroom. So please make sure you pay attention for that so you don't end up doing all of them, because I'm not going to assign all of them. All right, guys, so here we go. Letter A. Find 3 consecutive integers. So it looks like we're going to have n even integers plus 2 and plus 4. There's my 3 consecutive even integers such that the sum of the first and third, so my first is n, my third is n plus 4, equals the sum of the second plus negative 14, which is the same as minus 14, right? So let's put this together. 2n plus 4 equals n minus 12. I'll subtract n from both sides. I'm going to subtract 4 from both sides. All right, so my first unknown integer is negative 16. And when I put negative 16 in for the second one, I should get negative 14. And when I put it in for the third one, I'm going to get negative 12. So there's my 3 consecutive even integers. Negative 16, negative 12, negative 14, and negative 12. All right, letter B. The golfer used a 6-iron. That's a club, by the way, a golf club. But the ball traveled only 5/6 of the required distance. If the golfer hit the ball 180 yards, what was the required distance? So what I see here is that he hit it 5/6 of the distance, which happens to be 180 yards. So we can use this. This is not such a hard one to set up. So 5/6 of the required distance equals the 180, right? That's what the problem says. It says 5/6 of the required distance, so 5/6 of the required distance is 180. That's what it says, yards. So we can figure this out. I'll remove the time sign because I don't really need it there. Multiply by the reciprocal of 5/6. And the required distance, when you do your math on this, should be 216 yards. Okay, letter C, and this is the last one. 7/8 of the tickets had been sold, and there were 560 tickets left. How many tickets were printed? Okay, so let's write down what we have here. So 7/8 of the tickets were sold. 7/8 are sold. So that means 1/8 has to be what's left. And the other part that we know is the total amount that was left, and that was 560 tickets. Okay, so this is the information we're going to use to set this up. So 1/8 of the total is 560. You see that? So that both of these are connected because it's what's left. So 1/8 of the total is 560. So let's solve this. So I'll multiply by the reciprocal on both sides, and you're going to end up with 4,480. Okay? All right, guys, that was a long lesson because both of those concepts were in there. Please be conscientious to make sure that you're thinking if you're looking for consecutive odd or consecutive even integers, it's different than just consecutive integers, right? You got to skip 2 units instead of just 1. Okay, so have fun with that, and be on the lookout too for your review sheet. That I'll be working on that tomorrow and getting those uploaded for you so that you'll have those to work on this week as well. All right, guys, if you have any questions, please feel free to reach out to me. Have a great day. Bye-bye.